Now that we've seen the chi-square curve and had it introduced to us, we need to be able to find the critical values, just like we were able to find them for the z curves and the t curves in sections 9.1 and 9.2 respectively. So the notation for chi-square curve or chi-square critical values is chi squared, because it's still got to be squared, but with a little alpha with it. And the alpha is the area in the right tail by definition, just like it was for the t's and the z's. Quite frankly, we often notate it with an extra little thing down there, namely the degrees of freedom. So we'll put a little comma and then put the degrees of freedom after it because there are infinitely many curves, so it pays to know which curve we were talking about. Now we're going to use single tail values like you're seeing in this picture in chapters 10 and 12. But in chapter 9, we're going to need confidence interval ones, which actually look more like this. Right? You're splitting up your alpha into two pieces. So you have an alpha over 2 on the right and an alpha over 2 on the left. And believe it or not, those two areas are exactly the same. So if you can imagine if you took this one over here on the right and kind of separated it off and turned it on its head so that it balanced on this bottom line, it would actually look very similar to this other curve. All right, so there's two of them. Now, because of the notation here, you can't get away with what you did in T's and Z's. So in T's and Z's, we would say this is the positive one, over here is the negative one, same thing. But that's not going to happen on this one because they're not the same number, and that's what I wrote here. Unlike Z's and T's, where they were the same number, these are going to be two separate numbers, and so that's why they need two separate notations. The one on the right has alpha over 2 to the right of it. But the one on the left has 1 minus alpha over 2 to the right of it, because here's alpha over 2 on the left. The whole curve makes 1, so that means 1 minus alpha over 2 is over here on the right. Because remember that subscript notation, you can't avoid it. It means area to the right, no matter what. Having that in a subscript, meaning below the line, means automatically it's area to the right. Keep in mind, since this curve ends at 0, these values are both positive, and they're not going to be the same at all. They're going to be very different from each other. Now, this is not like curves you've looked at before. Just real quick, I ran back here to section 9.2 so you could see. With the z curves and the t curves, because 0 is in the center and it's symmetric, it's the same number on both sides. And that's why when we did these calculations in another page, for the critical t values and the z values, they worked the same way. We would find plus or minus 2.10, right? See right there in that blue? Plus or minus, because it's the same number on both sides. That ain't going to work in chi-square. It's not going to happen. And that means chi-square is going to be a little bit trickier for us. Okay, so let's start working with the chi-square values. Now the thing is that you only have the table available to you. You do not have a calculator. I mean, you could use computer programs like StatCrunch or something if you have that option, but you're going to have to use your table and your wits. So let's do it. So we want to determine the critical chi-square values in each of the cases. So I want the critical chi-square values corresponding to a 90% confidence interval with n equals 9. Okay, so I have a picture drawn here. Now the middle is 90% because that's our confidence interval, right? So I needed to figure out the area in the tails, and I found it to be 0.05, and let me prove to you why. Well, first of all, let me find the degrees of freedom, because degrees of freedom is super easy. It's n take away 1, right? And since n is 9, it's going to be 9 take away 1, which is 8. So that's our degrees of freedom. That'll be the row of the chi-square table that we go to. Now recall that our confidence level and our alpha are complements of each other. So that means that alpha has to be 1 minus the confidence level, right, because of the complement rule, which means it's 1 minus 0.90, which is 0.10. But that's the area in both tails. So we don't want that. We want the area in each tail. So we have to take alpha and we have to cut it in half to get 0.05. So it's 0.10 over 2, which is 0.05. All right, that's the column that we're going to use from our table. Well, it's the first column, let me put it that way. So column number 1 is going to be the chi-square table is going to be 0.05. All right, now we need column number 2 because you're going to have to find two separate values, right? You can't use the same value for both of them. So that's the one on the right we just found. The one on the left is going to be 1 minus alpha over 2. So I want 1 minus 0.05, which would be 0.95, and that'll be column 2. Okay, so now I need to go get the table because that's my only option. So I'm going to go to Appendix B and I'm going to find my chi-square table. There it is right there. I'm going to move this guy down here because I'm going to need him. All right, so let's see, chi-square table, let's think. We need 0.05 as one of our columns, and then we need degrees of freedom of 8. So right here is 15.507. That's one of them. Now for the other one, we want to go to the opposite side, and I drew a vertical line down the middle so you guys could tell what was going on. So the ones over here on the right side of this vertical line, they're on the right of the curve. So if you kind of look at the curve, they'd be over here on the right-hand side of it. The ones on the left-hand side of the line are over on the left-hand side of the curve. So I still want 8 for my degrees of freedom, but I want 0.95 for my column. So that gets me 2.733. Now notice those two numbers are totally not the same. They're both positive, but they're not the same at all. And that's what we expect from a chi-square curve. So we have two critical values. We have the one on the right and the one on the left. The one on the right is 15.507. And I labeled it with a little comma 8 to denote for me that the degrees of freedom here was 8. And then the one on the left was 0.95, comma 8. And there we have it. You found your first critical values for a chi-square distribution. Oops, and this is a typo. That should say chi-square there. Let me fix that. All right, so we're looking for the critical chi-square values for a confidence interval if alpha is 0.02 and n equals 25. All right, so if n is 25, that means our degrees of freedom is 24. And then we got to think about this. If our alpha is 0.02, that's the area in the right, well, that's the area in both tails, excuse me. And so we're going to want to cut it in half for the area in each tail. All right, so let me type that up. Okay, so here I've drawn the picture. I've got 98% in the middle. Now, where is that coming from? So remember that if your alpha is 0.02, the confidence level is the complement of your alpha. So you take 1 minus 0.02, which gets you 0.98, which means 98% in the middle. Oh, and by the way, our degrees of freedom is 24 because you take 25, take away 1. Right, so that's not too hard. That's the row you're going to go to in your chi-square table. All right, now the first column we're going to choose in the chi-square table is going to be alpha over 2. Right, so we have to take our alpha and we have to split it in half, and that's 0.02 over 1, or excuse me, over 2, which makes 0.01. So that's column number 1. That's going to get us the one on the right over here. So that'll be 0.01, and that means the other one is 1 minus alpha over 2, which is 1 minus 0.01. 1 minus alpha over 2, which is 1 minus 0.01, which is 0.99. So that's column number 2 from our chi-square table. So we're going to take the chi-square table and we're going to have to look for row number 24, not 25, 24, because that's your degrees of freedom, the 0.01 and the 0.99 column. So let me pull that table up. All right, so row number 24, now look, 0.99 is this column over here. And then 0.01 is this column over here. Now notice there's some symmetry. If it's the second column over here from the left, it's the second column over here from the right. And then we wanted 24 for our degrees of freedom. So that means 10.856 and 42.980. And remember, you don't want to actually draw on your table, but you want to kind of use your fingers and get to the same places I'm getting to with those little red boxes. All right, so that means that our chi-square values are 10.856 and 42.980. And there we have them. And notice the notation I'm using here. The 0.01, that was the one we got from the 0.01 column. That's the one on the right, which makes sense because 42 is to the right on the number line of 10.856, which is the one on the left. Never forget that this horizontal axis right there, that's the x-axis, the same x-axis you know and love from algebra class. 0 is over here on the left. So the bigger number should be on the right. And when you look at the table, you'll notice these numbers over here on the right are bigger than these numbers over here on the left. Right? All the numbers over here are smaller because they're on the left side of the curve, and that means closer to 0. All right, so we did that one, and we also answered the question of the confidence level. They asked us that, so we got that in there with the 98%. And then we found both the critical values. Now this particular one actually doesn't want us to find both of them. It actually only wants us to find one of them, the one on the left, in fact, right? Because it's 0.995 comma 17. So the area to the right of that is, oops, the area to the right is 0.995. And I just realized I forgot to change this label in here. So this should say 005, and so should the other side. And in case you're wondering, I actually did have the computer program draw these with different degrees of freedom, but you can see they don't look that different when they're looked at separately from each other. You'd have to have them kind of drawn together to be able to tell which one was which we don't have here. Okay, so they want us to tell us the confidence level and they want us to find the critical value. So we got a whole bunch of work cut out for us. First of all, we know that 0.995 has to be 1 minus alpha. So it has to be the area in the right tail. Right? Which is 1 minus alpha over 2. Right? Since you're talking about having that much to the right of it, remember that that notation is area to the right by definition. Right? Since it's area to the right by definition, the only way this can happen is it's got to be on the left-hand side. Right? Put another way, look at the table here. We said earlier that all of these ones over here on the left, they're on the left-hand side of the curve. And 0.995, my friends, is right there. Right? That means you have 99.5% of the curve to the right. See the word right up there in the title? So this is by definition on the left-hand side because that's how you're going to get 99.5% to the right over here. Okay, so the area in the right tail is 1 minus alpha over 2, that's 0.995. That means that the area in the left tail has got to be 0.005. Oh, and I forgot to mention just real quickly that the degrees of freedom of 17 is given, right? That's that notation, right? When they say comma 17, that they're giving you the degrees of freedom. You don't have to figure out what n was. If you're curious, n was 18, but degrees of freedom is what we need. Okay, so let's look at this picture here. And I'm just going to try to explain this one more time. So the area in the right, to the right of this value, because we're talking about this one down here, this is the one that's 0.995. It has to be, right? So if that's the one that's 0.995 comma 17, as a matter of fact, okay, that means that you have 99.5% of the curve to the right of it. Right, and that means that this little guy in the tail is 0.005 over here. That's what we just figured out right here with this one. So that little tail on the left is 0.005, and the area to the whole right of it is 0.995. I guess I don't have to call it the area in the right tail. It's area to the right of the critical value. There. It's the area to the right of that chi-square critical value that we're trying to find. It's by definition 0.995, but that's also by definition 1 minus alpha over 2. And that means that alpha over 2 has got to be 0.005, the remainder, because they're complements of each other, right? If you look at that line at 0.995, chi-square 0.995, you have 99.5% to the right, 0.005 to the left, or 0.5%. Okay, so this is going to be this area to the right, that's 0.995. That's going to be the column that you're going to go to in your table. That's the one you actually need. You're not going to grab another column because you're only interested in that particular one. If they wanted you to find the other one, you would use the 0.005, right? Okay, so then we just need to go to the 17 row and the 0.995 column. They only asked us for one of the values, so we don't have to find the other one. I mean, if you're interested, the other one would have been 0.00517, so it's over here, 35.718. That's the one on the right. But they didn't want that one. They actually only want the one on the left, which is 5.697. So that's our critical value. Now the question becomes, what confidence level would that be? Well, if your alpha is 0.01, because it's 0.005, I think that's a little bit unclear. It's 0.005 times 2, right? So you multiply by 2 to get your alpha over 2 times 2. Here, let me show it to you. It's alpha over 2 times 2. That will get you your alpha. So it's 0.01 right there. Okay, so if that's the case, why do I need to figure that out? Well, because the confidence level and the alpha are complements of each other. So that means your C level is 1 minus your alpha, which is 1 minus 0.01, which is 0.99, which gets you 99%. Okay, so we have a whole bunch of information going on. I actually found the critical value before I found the confidence level, but that's all right. So the critical value is over here. It's 5.697, which makes sense. It's on the low side. It's close to 0. And then you have a confidence level of 99% in the middle because you have 0.005 in one tail, 0.005 in the other tail. Together they make 0.01. And then you take that away from 1 and you'll have the complement, which is the confidence level in the middle. That's 99%. Okay, we're done with that. We now know how to find all our chi-square critical values. And now we'll come back and find some confidence intervals in the next video.